All right, chapter 16. We are learning about the normal distribution. The topic is called continuous probability distributions. But 16a is all about relative frequency and reviewing some of the things that we have already learnt. So the first things on the top of the page says the HSE reference sheet has the following two formulas that we looked at in year 11. So here's some year 11 content to revise. So E of x is expected value of x. It is the same as the mean, which we give the symbol mu. Or x bar, just because we like to call it different things. Okay? Variance is the standard deviation squared. So you always find that first when we were using our tables last year. So it can be found by the expected value of x minus mu in brackets all squared, or expected value of x squared minus mu squared. The following formulas are not on the reference sheet, but are very helpful ones to know. The expected value of x, we know that that's mu, but it's also the sum of x times p of x. Okay, so if you're using your table, your x times p of x, that's like summing up all of your scores in the table. Variance, we've talked about the first. This one was on the formula sheet, but this one here is not. Okay, and then there's these other versions as well. So the first one was on the study sheet, but summing's the second one, the ones that we use from the table. And variance, if you square root it, you get the standard deviation. That's an easy one to remember, I think. Okay, cumulative distribution function. In year 11, we did not discuss the cumulative distribution function, but it is easily defined. If we consider throwing 4 coins and recording the number of heads, then the function f of x is obtained by adding all the probabilities up to a certain point. Now notice that is a capital F of x. When we use a capital, that represents cumulative. And we'll be using that a lot more in the next exercise, but it is used here, so it's worth a mention. So lowercase f would just be normal function of x, but capital F in this exercise, or this chapter, is going to be talking about cumulative function. So throwing 4 heads, the possibilities, we get 0, 1, 2, 3, or 4. The probability of each of those have been calculated for us in here. They're the probabilities of getting each of those, which we could calculate if we wanted to, but they've given them to us. And to get the f of x, we are adding these up as we go. So 1/6 plus 1 over 16 plus 4 over 16 makes 5 over 16. Add another 6 and we get 11. Add another 4, we get 15, until you're getting a total of 1. It's because the total of all probabilities should always be equal to 1, so that last box should always be a 1. Relative frequency is found by taking your frequency and dividing it by the total number of things that you have in there. So 7 divided by 100 is 0.07. 29 divided by 100 is 0.29. So it's a lot like probability. You're taking the total number of items in this data. There was 100, and it's 7 out of 100, but it's expressing it as a decimal. A summary. For the data set, the relative frequencies and cumulative frequencies are obtained by dividing by the total frequency. We just did that. The relative frequencies of a data set are estimates of probabilities. For this reason, they are often referred to as experimental probabilities. The cumulative distribution function f of x of any numeric probability distribution is the probability that the score is less than or equal to the x, because it's cumulative. So if I say I want capital F of 2, it means everything up to 2 because it's cumulative up to that point. The cumulative relative frequencies are estimates of the cumulative distribution function. I guess we're using the word estimates because we are basing these on theoretical probability. In practice, they might not work out this perfectly if you were to start throwing coins and things and getting your results for yourself. The histogram and polygons of these relative frequencies and cumulative relative frequencies are drawn in the usual way, so we'll be drawing one of those. Okay, so 2 quick examples. A chicken is wandering randomly around a 20 metre by 20 metre square enclosure. It is just as likely to be at any one place in the enclosure as any other. A circle 10 metres in radius has been inscribed in the square. If Farmer Brown looks out at the enclosure, what is the probability that the chicken is inside the circle? Okay, let's draw it. We have a 20 metre by 20 metre square enclosure. Inside that enclosure, there is a circle with a 10 metre radius. That means the circle has to actually be touching the square because that would be a diameter of 20. Okay, so that radius is 10 metres. Okay, so the chicken is wandering around in the yard and we're saying that it's just an equal probability that it could be anywhere. It's not more likely to be in one spot than somewhere else. It's equally likely to be anywhere in that square. And the farmer wants to know the probability of it being inside the circle. So I need to find the area of those 2 shapes. The area of the square is 20 times 20 or 20 squared, which is 400. The area of the circle is pi r squared, so that would be pi times 10 squared. I'm going to leave it in exact form. That would be 100 pi. So the probability that the chicken is in the circle, I have to turn this into a fraction. The probability will be equal to the chance of it being inside the circle, which is 100 pi, out of the total area of the yard, which is 400. Making it into a fraction is now probability. 100 over 400 simplifies down to be 1 over 4. So it's a pi over 4 chance if I do it exact. Obviously, you could find the decimal answer if you wanted to. Okay? Question 2. Copy and complete the following table by filling in the relative frequencies, cumulative frequencies, and cumulative relative frequencies. Okay, first thing in the second row, we are missing a number, the total, so we want to add all these up. 3 plus 1 plus 4 plus 3 plus 1 plus 3 plus 1 equals 16. Okay, we need that number to do this. Now, F with a little r, that's talking about relative frequency. So I want to take my frequency of 3 and divide it by the total, which was 16. So it's 3 out of 16. The next one will be 1 out of 16. 4 out of 16. Obviously, some of these will simplify down, but I'm not going to do that yet. 1 out of 16, 3 out of 16, and 1 out of 16. If you add all of those up, what should they equal? What do they equal? 1. Okay, if we're dividing it out of 16 and adding all those parts up, yes, of course, that should make a total of 1. Now let's do CF, which is cumulative frequency. That is talking about this frequency row. I'm adding those as we go. So 3 is my first number. I add on the 1 to get 4. Add on the next 4 to get 8. Add on 3 to get 11. Add on 1 to get 12. Add on 3 is 15. And add on 1 is 16, which makes sense. There was 16 in my sum when I added those up. So when I do cumulative frequency, I should also be getting 16 at the end there as well. Okay, now to do cumulative of my relative frequency. So that's going to be accumulating this row. So starting with 3 over 16, that's why I wanted to leave them as 16s, because then they're easier to add on. So 3 out of 16 is my first number. Add on an extra 1 will make 4 out of 16. Add on another 4 will be 8 out of 16. Then add on 3 is 11. And then 16 out of 16 makes 1. Okay, I could have done that from this row or this row. I was doing it from there. I could have just as easily divided that by 16 to turn those into cumulative relative frequencies. Part B, construct a cumulative relative frequency histogram and polygon. Mark your vertical axes in divisions of 1/8, which is 0.125. Boys, can you turn your computers off while we're doing this, please? So I know that you're concentrating up here. Okay, so across the bottom is going to be the X. We need to draw the histogram, which means I need a column width. So I'm going to do every second space so that I have enough room for that column to go in. So this is going to be 1, 2, 3, 4, 5, how far do I need to go? 7, 6, 7. Okay, then on the vertical axis, it tells me to do 1/8 for each space. So there'll be 1/8, 2/8, 3/8, 4/8, which is a half, 5/8, 6/8, 7/8, and 8/8, which is 1. This is the cumulative relative frequency that we're going to be sketching here. So that means these ones across the bottom. Okay, so 3/16 would be 1.5 when they're 8s, so it will be there. Is that okay? Because mine was out of 16ths, but my scale is out of 8s. All right, so going on to 2, 4/16 would be 2/8. So that's going to go to here. 3 is 8/16. How many 8s is that? 4. Good, so we're up to 4. 4 is 11/16. How high am I going now? 5.5, yes. 5 is 12, which is going to go up to 6. 6 is 15 over 16, which will be 7.5. And then 1 should be all nice and neat and ruled, nice perfect straight lines. Okay, then we need to also draw on there the polygon. When it's cumulative frequency, it goes from corner to corner, not the center, which the normal histogram does. We need our first dot in the bottom corner of that first column. Then we go to the top right-hand corner of each column after that, and then you carefully rule your line segments in between. Okay. From the graph, it says use the ogive to read off the 3 quartiles, Q1, Q2, and Q3. Now, if it's from a graph, and my graph is going up to 1 is my value here, then to find my quartiles, I am splitting the space in half. Half of 1 is going to be 0.5. So you need to mark this on your graph. 0.5 is the 4 over 8. And we're going to draw a dotted line coming across to the red ogive, and then straight down. So different colours, even the blue you can't see very well. Maybe I'll change it to black. There we go. So we're coming across and down. It's a little bit easier to see. And we want to read off the number that is down here. So because it is right on that corner, it is between the 3 and the 4, which means I would put down 3.5 as my Q2. That's the median. That's the middle of all of the data. If I want the lower quartile and the upper quartile, I have to halve the lower end to find the lower quartile, halve the upper end for the upper quartile. So this is 0.5. When I halve that again, it's going to be 0.25 or 2/8. So I'm going to draw my dotted line across. Again, it's right in the corner and down. And so my lower quartile is going to be 2.5. Where is my last line going to be drawn up here? For the upper, the 6/8, that's right. Come across and down. And so my Q3 is 5.5. And that's all you need to do for 16A.